Okay.
You might watch it like in 2 years.
Yeah.
Just watch like the beginning of it.
I don't need it.
End of it.
Hey.
Yeah, I'm gonna be too.
What we're doing today is looking at uniform and non-uniform distributions and properties.
I just want to watch it. No, let's watch the end of it.
All right. Now, although I put non-uniform distribution there, I'm going to put a lot of attention on uniform distribution. If you know what to do with uniform distribution, you should know what to do with non-uniform actually. A lot of the examples I gave you last few days, they are all on non-uniform distribution. So I'm going to concentrate on uniform distribution. You must be able to define a uniform discrete random variable and its associated probability mass function, and be able to generalize the mean and variance of a uniform discrete random variable and able to solve problems. Alright? So now, let's talk about rolling a six-sided die. Alright? Now, if it is fair, rolling one of this die,
The points where it's like
six-sided,
2 pi over 3.
you would know that the probability, the outcome, will be just 1, 2, 3, 4, 5, and 6. So therefore, if you look at the probability mass function, the probability of x equals to 1 is
1 over 6.
1 over 6. X equals to 2 is 1 over 6, and so on and so forth.
Theoretically.
And you plot the histogram, it will look that way.
Wow.
Yeah.
Uniform.
You can describe it as symmetrical,
Unimodal.
it is unimodal, and it's rectangular.
Yeah.
Right? So, what we're going to look at is concentrating on the probability mass function with the probability everything is uniform. And when you draw it, it will be something like this. If you draw the histogram. So there are many situations, such as rolling a six-sided, a fair six-sided die, tossing a fair coin, a uniform spinner, and so on and so forth. Right? In the case whereby each outcome of a probability experiment involves a discrete random variable, which is equally likely and the distribution is symmetrical, equally spaced across an interval, it is said to be uniform. So you must think about it as equally likely, and you must think about it as equally spaced. Alright? As well as symmetrical. So three things: equally likely, symmetrical, and equally spaced.
So,
Yep.
will we get questions where it's like very close to being like that, and you can just say it's uniform as well?
Don't know, haven't looked at any question like this at all.
Okay, right.
Alright? Probably, I don't know. Alright, now, let's have a look at a discrete random variable x. If x is uniformly distributed from x equals to a to x equals to b. So what I've plotted here, I've used a straight line to show you instead of the histogram. So I've got a here and b there. So it's distributed, it's uniformly distributed from x equals to a to x equals to b, such that there are n equally spaced integer outcome. So there's 1, 2, 3, 4, 4 equally spaced integer outcome between a and b, whereby the distance between each value of x is k. So what you really think about is the distance between here. That's k. That is k. K, and that's k. Alright? The probability mass function for x is therefore defined as p equals to x divided by n. For x equals to a plus k. Yeah. A plus k, a plus 2k, a plus 3k, so on and so forth, until you have b minus k. Right? So it depends. So that's b minus k. Now, you've got to know what n is. N is b, take away a, plus k. Alright? We'll talk about the unique situation when k equals to 1 in a few minutes. But you've got to think about that. This k could be 1, could be 2, could be 3. But they need to be equal. K has to be the same, the interval. So here you can see that there's an interval, n equals space, and that's 1, 2, 3, 4. 4 of them. Right? equally spaced integer, equally spaced integer, which is and not the space here, equally spaced integer. So therefore, the probability will simplify to 1 over n. All right. So think about that. K. I'll show you an example later. K equals b minus a. That's n, and it's k over n. All right. So when k equals 1, that's a unique situation. The probability of x equals to x is 1 over n. Again, this time it's a plus 1. If k is 1, a plus 1 is here. If k is 1, a plus 1 is here, a plus 2 is here, a plus 3 is here. Or a plus 3 in this case is b minus 1. Correct? Yeah? So, you can see that discrete uniform distribution can be denoted using x, a squiggle uniform, n. Alright? So those two you should know. Can you
I don't know.
write this down, please? In your notebook if you want to. If not, you've got it.
So what,
Anyway, highlight that.
what does squiggle mean?
Squiggle is just say that it's a uniform distribution. That's all. X is a uniform distribution. All right. Now, let's have a look at the two things. The first one, the first situation, I have got a discrete uniform distribution, and you can see that I have got 5 numbers from 3 to 7. In this situation, k equals to 1, right? You go from 3 to 4 to 5 to 6 to 7. Now you can actually verify that n equals to b minus a, 7 minus 3, which is 4, plus 1, which is 5. So therefore the probability is 1 over 5. Alright? You should be able to work out n. Now the next situation is you got still the same 5 outcome. However, this time you've got 4, 7, 10, and 13. These are uniform between here and here, and they are k equals to 3. Alright? Notice I use a small k throughout, but in this situation I use a big N. 3 over n, big N. Alright? Because there's a k over n. This is a small k, which is same for everyone. I use k. This is 1, this is 3, k over big N. And therefore it's the same as 1 over 5, which is 1 on n. Alright? So you need to think about the difference, what the difference is in between the numbers. It has to be equally spaced. Alright? We're going to do some examples. Now, if you look at the probability mass function, Px equals to x equals to 1 over 4 for a discrete random variable. It's defined over each of the following set of x. Give a reason whether each of the discrete random variable are uniformly distributed. Let's look at the first one. You know that there are 4 elements in there, 1, 2, 4, and 8. Alright? Can we say that it's uniformly distributed?
No.
Because it's not equally spaced. 1 to 2 is, the difference is 1. 2 to 4, the difference is 2. 4 to 8, the difference is 4. So, answer is no. Although the set consists of 4 equally likely integers, they are not equally spaced. So it is not. What about the next 2?
Yeah.
Are they equally spaced?
Yeah. Yes.
So they are equally spaced. You can see that the mass function is 1 over 4. So you can even work out 1 over b minus a plus 1 equals to 1 over 2. 2 minus 1 plus 1, which is 1 over 4. Alright? That works. What about the next one? The third one?
Yes.
Yep. So it's the same answer.
10 on
4 equally likely and equally spaced integers. So therefore, we can work out k equals to 10. Again, k K is B minus A, the probability is K over capital N. Capital N is B minus A, last number take away first number, plus the difference. 40 minus 10 plus 10. So therefore 10 over 40, which is 1 over 4. Same, 1 over N. Alright? You need to think about whether it's equally spaced, and you must be able to work out the probability. Alright? That's example 1 for you. Now, going on to before that, let's have a look at the expected value and the variance of a uniform distributed, a discrete random variable. Alright? Now, use the same thing. You can still use expected x equals to, which is mu, equals to sigma of x times probability of x. Alright? There's a different way of doing it. You know that the probability of x is always the same. Right? That will be the same. X minus, you can work out the mu. Alright, the expected value. Now, it can be used, the more specific formula on the next slide is quicker and easier to use. So I could just use the expected value for x in a uniform situation is the first number plus the second number divided by 2. Because this time the weight is the same. See, there's no, the weight is the non-uniform that we have been doing. The probability of the weighted average is different. Therefore, we need to use the weighted average. This one, you can see that because they are all the same, uniform, A plus B divided by 2, the midpoint, that's all. Alright? And this, you can use this pretty straightforward. I won't derive it for you. It's just the variance of x is k squared into n squared minus 1 divided by 2. That's all. Alright, if you could, don't know whether this is in your formula sheet, let me check. It is not in your formula sheet, but you can use that, alright? So you might want to put that in your
This
notes.
kid here already has nothing. This guy here already has nothing.
It's not in your formula sheet.
Look at that father.
Alright, next bit.
Nothing anyway.
So can you work?
He has nothing.
Let's have a look at example 2. Consider the following random variable x defined by the following probability mass function. B of x equals to k over 34. Alright? Now, you know that x is an element of 1, 4, 7, 10, 3, 16, 19, and 22. Alright?
Still decent enough.
Now, what type of distribution is x? And you need to give a reason why.
Uniform.
It is uniform. As it is consists of 8 distinct and equally spaced outcomes.
Yep.
So you know the equally spaced. Part B, you could use this because 8 times k over 24 is equals to 1. Therefore k equals to 1. You are adding everything. So if the probability of this is k over 24, probability of k over 24, so you add that 8 of them, 1, 2, 3, 4, 5, 6, 7, 8. 8 times k over 24 equals to 1. Therefore k equals to 1.
K
Alright.
equals to 3.
K equals to 3, not k equals to 1.
That's
K
the
equals
number
to
of
3.
elements in the set. So since every single one has a
That
set
is the
number,
way, that's a
it's
good
just
way of
8
showing it.
times
Alright?
That one constant problem is 1.
Unless you want to work out all the differences. 3. But you don't have to. This is easier way of doing it. So if you keep on thinking about k is 4 minus 1, k 7 minus 4, k is 10 minus 7, you keep doing
At the
that.
same time.
You understand? But that is probably a lot better. A lot neater.
And shut the same time.
Alright, part C. Determine the value of the x variance of x and SD of x, standard deviation. So you know that expected value of x is just a plus b divided by 2. You no longer need to work on the the probability. It's no longer, you don't need to think about the weight now because everything is the same. It's uniform. So just 22 plus 1 divided by 2, which is 23 divided by 2.
And then SD would be just 3, right? Because that's the average spacing. Oh, wait, no, that's not.
SD,
K squared N squared.
You got to work that out.
Yeah,
It's
okay.
3 squared. K is the formula that I gave you just now. 8 squared minus 1 divided by 12. So it's actually 189 divided by 4.
Classic. That's a standard dev.
And if that's the case, 189 divided by 4, the standard deviation is square root of variance. So that is 3 root 21 over 2.
Crazy.
Of course, if you got a calculator, you give it in 2 decimal places. I did this without calculator.
Yep.
Alright. If this is in a calculator free section, I'm not sure whether you need to simplify the certs. Alright? Probably, maybe yes, maybe not. I don't know. Yes, really speaking, if this is in a calc free section, if you need to work out the standard deviation, which is square root, you should actually give your answer in a simplified cert. Alright? And finally, calculate EX, expected value of 2x plus 3 and the variance of 2x plus 3. So you know from previously, we can just E of 2x plus 3 is expected value of 2x plus 3, which is 23 plus 3.
Isn't it 2 at the front and then EX?
Oh, it can be that way. It can be, doesn't matter. It's still the same. 2x and 2 times EX is the same.
Yeah, okay.
Yep. Which is 25. And then the variance is 8 squared, 2 squared times that. That's it, which is 189. Alright?
26.
26. Is that 26?
Sorry?
23 plus 20.
26, sorry.
23 plus 20.
23 plus 23 is 25. I love that. Okay, I'll sort it out later. Alright. Let's do example 3 first. A bag contains identical discs numbered 10 to 19. A disc is drawn at random and returned to the bag. Let R represent the number on the disc drawn. So I'm not using capital X now, I'm using R. Alright, name the type of distribution R is and hence state the probability mass function for R.
Uniform.
Uniform. And how do you do that? How do you state the probability mass function?
It's 1 over 9.
1 over 9? Is that all? What about all the other numbers?
1.
0.
0.
1 over 10. Is 10 to 19 is actually 1 over 10, included 0.
Piecewise.
So, you need to think about probability of R equals small r. So for R equals to the disk, which is 10, 11, 12, 13, 14 to 19, they are all 10, they are 10 together. Right? So therefore the probability is 1 over 10. Anything else is impossible. You cannot have anything greater than 20 or less than 0. Less than 10, not 0, because you have not labeled anything. So therefore, for probability mass function, you should always state that what is R? What R should be, because it's 10 to 19, and that's 1 over 10, equally likely happen, uniform, 10 discs in there, and the rest is 0. Alright, this is how you should always state a probability mass function if you're asked to do it. Alright? 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.
Yeah.
Include the 0 as well.
Yeah.
Alright, include the 0. Yeah? So from there, you should be able to work out probability of R equals to 12, which is 1 over 10. 15 and 17, 15, 16, 17 is 3 over 10. And probability of R equals to 12 given that R is less than 16. So R equals to 12 is 1 over 10.
Yep.
R is less than 16, 10, 11, 12, 13, 14, 15. 10, 11, 12, 13, 14, 15.
Oh,
6. Alright? So it's 1 over 6. Now, instead of writing the expected value of R, I use the mu R, and instead of standard deviation of R, I use sigma. Alright? So you must be able to understand what they are, mu and sigma. That is standard deviation, that is mu, which is expected value. So you must understand those.
10 take 9.
Expected value or the standard deviation. To calculate the standard deviation with a calculator, of course you need to use your work out the variance first and square root it.
Yep.
Alright? So the mu r is just a plus b divided by 2, midpoint 14.5. And then this one you need a calculator.
Yep.
So the case 1 square,
I'm gonna just root 99.
and 10 of them, 10 square, take away 1 divided by 2.
No, divide by 12.
12, not 2, sorry.
99 on 12, yeah.
Yes. What did I say? 2. Yes, divided by 12.
Formula is always
Ah,
Yeah.
so,
it's always 12.
and then 2.87. And then you can work out if t equals to 20 minus
root
30 minus
33.
3r, you can work out mu t and
It's
sigma
root
t.
33
So
on
one
12.
is just 20 minus 3.1.45. The other one is just 3
Actually, root
sigma r,
33 on 2.
which is 8.67. All right.
Root 33 on 2.
Yes. Pull out a 3.
Last example.
Smarty pants.
There's no more examples.
Oh, actually, this is
3
the
times
last
4.
example. That's it. So, that's the end of the lesson. First time, half an hour.
Wow.
All right.
Yeah.
Less than half an hour.